everyone! So area and volume are common topics in Calculus 1 that show up towards the end of the course. And this video is all about volume. And if you'd like to see other videos where I talk about volume using cross sections or area of a region, make sure to check out my channel so that you can watch those videos and help your learning of calculus. And in this video, we're going to look at the region R. And the region R is the area enclosed by the function f of x equals 2 root x and the horizontal line y equals 4, and also the y-axis. And we're going to find the volume of the solid generated when the region R is revolved about the line y equals 4. How fascinating is this? We're going to use calculus to find the volume of this three-dimensional region that's made by taking a region and revolving it. And if you find this video useful, make sure to give it a like. Comment below while you're watching this video about any questions you have, and make sure to subscribe because I post weekly videos on calculus and you'll be notified of those videos as they are posted. And once again, check out my channel for other videos on calculus and also videos to do with area and volume, which, like I said, is towards the end of Calculus 1. The first thing I need to do for a problem like this is I want to look at this region, and it is already graphed for us below. So I'm going to label a couple things. Here is my function f of x, and that's going to be the 2 root x function. And then you've got the horizontal line above at y equals 4, and then also the y-axis to the left. And I want to revolve this region about a horizontal line. This is going to be my axis of revolution, in which we're going to take that region and we're going to revolve it around this line here. Because we are revolving a two-dimensional shape around a horizontal line, we are going to be taking cross sections that are perpendicular to that horizontal line. So when we find this volume, we're going to set up an integral, and it's going to be a dx problem. Keep that in mind. So when we go to set up this integral, which means we're going to sum up an infinite amount of these cross sections from revolving from this first x value, which we can see is 0, to what is this final x value? Well, it looks like it's 4, but instead of just assuming 4, I do want to definitely prove that it is at an x value of 4. So if I plug in 4 into f of x by finding f of 4, I would get 2 root 4, which is 4, and I can see, in fact, yes, that does align with the graph. So I know I'm going to go to the x value of 4 when I calculate this value. Now, if I think about revolving this region, I want us to think about what the cross section would be. Now, I have recorded a video about cross sections, so if you want to see a video where I talk about where a cross section is a square, click here. Or to see where I've done a problem where the volume is an equilateral triangle, click here. In this problem, when you revolve a two-dimensional region, the cross-section is going to be a circle. So for this problem, we do need to recall that the area of a circle is pi r squared. So the integral symbol tells us that we are summing up an infinite amount of circles. So we need to sum up an infinite amount of shapes with an area formula of pi r squared. Now, since pi is a constant, I'm going to bring the pi out in front. So all I need to calculate then is what is this radius, because that's what's going to then come after the integral, and then I will square that. Well, if I were to take this shape, and I'll do as best I can here, you take this shape and we are revolving it. Think about each cross section. Woo, that's pretty bad. But if you can envision this, each cross section is a circle, and the radius is going to be this distance right here, or the distance on top, either way. So to get this distance right here in red, I would be taking the difference of those two functions, and that'll give me that radius. So in this case, the difference of those two functions would be 4 minus f of x, which is 2 root x. and that is the radius. So it would be radius squared, and because I'm adding an infinite amount of circles that are perpendicular to the x-axis, or in this case, perpendicular to the horizontal axis of revolution, this is going to be a dx problem. So I did want to make sure that I had written everything in terms of x. From here, I can just plug this into my calculator so that we can get the answer. And there it is, 33.510. And once again, what we've just done is we've calculated the volume of this three-dimensional shape where you take a two-dimensional figure and you revolve it so that each cross-section is a circle, and we added up an infinite amount of those circles between the x value of 0 and the x value of 4. So that's it, another problem in the wonderful world of calculus, and I hope you found that video useful. If you did, make sure to subscribe, give it a like, comment below about any questions you have or any comments about the video, and keep watching weekly for videos that'll help you with your learning of calculus. Have a great day, everyone, and we'll see you next time. Bye!